15.2. Okay, now we're going to have some real practice of calculating the molarity. So last videos, okay, we did learn two equations. The first one, molarity, or in the unit of mole per dm cube, or capital letter M molar, okay, equals to number of mole over volume. Okay, last video I didn't emphasize, okay, again, actually for me I didn't use this format, okay. So normally, okay, number of mole over volume, right? So I will rearrange them, so therefore I will make it like number of mole equals to mv. Okay, so it will be easier for me to remember. Okay, number of mole equals to mv. Okay, so while the other ones is the relationship between the concentration and molarity. So this one I mentioned last time, concentration equals to m times mm. Okay, 3m together. So these videos we're going to use these two equations to help us out, okay, in doing all kind of calculations. So the first one, okay, calculating the concentration of solutions. So in this questions, okay, we'll have like 100 cm cube. We got the volume. We know that it's sodium carbonate, which is Na2CO3, and then it contained 0.25 mole of sodium carbonate, and then you need to calculate the molarity. So now we have volume, and then we have number of mole. So we have these two. Okay, so first of all, part A, we need to calculate the molarity. Part B, we need to calculate the concentration. So for first part, okay, you have number of mole equals to mv. Okay, so you have 0.25 m and then 100 over 1000. You turn it into dm cube first. Okay, so therefore the m for the first part will be 2.5 mole per dm cube. Okay, so basically like that. Second one, okay, from the molarity go to the concentration, because we have concentration equals to m times mm. So therefore we have 2.5 from the previous part times mm. Okay, that will be 23 times 2 plus 12 times 16 times 3. Okay, so this one will be the molarity times the molar mass. So for this one, okay, it will be 265 gram per dm cube. Got it? Okay, next. So this one, okay, we'll have 250 cm cube of sodium sulfate, and then we have like 14.2 grams. So we have the volume and then we have the mass. So you have volume and mass. Okay, first part you need to calculate concentration. Okay, this is part A, concentration, and then you need to calculate the molarity. So basically you have concentration equals to mass over volume. So you have 14.2 over 250 over 1000. Okay, so it will be 14.2 over 0.25. So the answer for this part, okay, will be 56.8 gram per dm cube. Okay, next, concentration equals to m times mm. Okay, so you have 56.8 equals to m times sodium sulfate. Okay, it will be sodium sulfate will be Na2SO4. So it will be 33 times 2 plus 16 plus 16 times 4 plus 32.1. Okay, so m will then be 0.400 mole per dm cube. Okay, so like this. Next, calculating concentration of solutions. Okay, so this one is a very important example. Okay, among all the examples here, okay, this one is very important. Okay, sample, okay, we have 100 cm cube of concentrated nitric acid, has a density of 1.51 gram. This one, okay, we are giving you a density. Okay, we are not quite used to density actually. So do remember one of the function of density where is to allow you to find out mass. So if I have con nitric acid, say for example right now, okay, we have corn nitric acid. Okay, this one is 100 cm cube. And then you have density, which is 1.51 gram per cm cube. With volume and density together, okay, you can help to get out the mass, okay, because you have volume, okay, you need to have the density with the volume times the volume will equals to the mass, okay, because density equals to mass over volume according to the symbols here, okay, for the units here, okay, is mass over volume, okay. So what you need to do is just times the volume, you times the volume, and then you got the mass. So to modify this three-path diagram, okay, you may try to write maybe density, okay, you just need to times volume, and then you can find the mass. So first of all, okay, I will just make it simple first, okay, we'll have the mass of corn nitric acid, okay, that will be 100 cm cube times 1.51 gram per cm cube. Okay, I try to align the unit. This one is cm cube, this one is cm cube. So therefore this one, okay, you first of all you have 151 gram first, okay, but you have to realize that this 151 gram, okay, this one is 151 gram, okay, is not all because of the nitric acid. Quite a number of them is the water. How do I know that? Okay, so you have to pay attention to this one, okay, because they have 68% of nitric acid. That means you still have 32% that is not nitric acid. What are they? They should be water. So if I draw like this way, so maybe you have like 68% nitric acid here, and then you have 23% water. So if you try to calculate the molarity of the acid, okay, you have to find out the mass of this one first. So this one actually is not difficult, okay, because you know the total mass already. So mass of HNO3 would then be equals to 151 times 0.68. That means 68%. So this one will be 102.7 gram. Okay, so after you do all this, okay, you will find the mass already, and then our ultimate goal is to find out the molarity of the solution. Okay, so you may go down this way. Okay, so first of all, we calculate the number of mole first. Okay, so number of mole of HNO3 will be equals to 102.7 over 1 plus 14 plus 16 times 3. So for this part, it will be 1.63 mole. Okay, next, okay, that will be the molarity of HNO3, will then equals to 1.63 over, okay, the volume with 100 cm cube, but remember you have to turn it to dm cube first, okay, so this one will then be equals to 16.3 mole per dm cube. Okay, so this is a very important examples, okay, because you have integrated the concept of density and also integrate the percentage by mass right here, okay. So do remember the chemical, if it's acid or things like other kind of solutions, part of that will be due to the chemical, part of that will be due to the water, okay. Next, okay, self-test, okay, you have 15.1 to 15.3, okay. So you pause the video, go through it on your own. Number of moles of solute, okay, so this one, calculate the number of moles of magnesium chloride. You have to calculate this one, okay. We give you the volume and also molarity. Pretty simple. I give you this one, I give you this one, you have to find the number of mole. So what you need to do, just go back. So remember, number of mole equals to mv. So number of mole equals to 2m times 250 over 1000. Okay, so for this one, okay, will be 0.5 mole. Easy. Next, okay, we calculate the volume of solutions. Okay, in this questions, I give you 0.25 m. I give you this one, and then I know that we have 0.1 mole. So you're looking for the one in the missing. Okay, what is the volume of the solutions? Basically, we use the equation, number of mole equals to mv. Okay, so you have 0.1 here, okay, you have 0.25, okay, you times volume. So volume you find out will be 0.4. Remember the unit here will be dm cube. If you convert it into cm cube, that will be 400 cm cube. Okay, so you multiply this one by 1000. Get it? So this time, okay, we are going to find out the mass. Okay, we found the mass. We are giving you like 250 cm cube. We got the volume. We got 0.5 molarity. We got the molarity. Okay, so do we have mm? Yes, we have mm because we know it is NaOH. Okay, so first of all, okay, we calculate the number of mole first because that one will be starting point. Okay, you go this way, going up, right? So first of all, we find out the number of mole. So number of mole equals to mv. Okay, so therefore you have 0.5 times 250 over 1000. Okay, that will be a number of mole. Okay, will equals to 0.125 mole. And then next, okay, you will find out the mass. Mass equals to number of mole times number of moles times mm. Okay, so that will be 0.125 times 23 plus 1 plus 16. Okay, so for this one, okay, will be 5 gram. Easy. Oh, so your practice time, okay, self-test. And also you got 2 more exercise. For this exercise, I think the most important one, again, that will be class practice 15.1 question number 3. Okay, this is a very good questions and also important because many of you don't know how to do the math for this. So do tag it, okay, in your textbook. Okay, so you when you revise for exam, okay, you go for this one. And also 15.2, okay, please help yourselves and do it on your own. And then, okay, for a summary, okay, I make use of this table quite a lot, okay, so better remember how does it look like and when to use it, okay. And also for these 2 questions, one is example 15.3, one is question 3, okay, those are good exercise, okay, so do practice a few more time, okay. Remember, whenever you see density, it is an important information to help you to find mass, okay. The value of density is to help you to find mass, okay. The relationship between these 2 is density times volume equals to mass, okay. So next point I want you to remember is, okay, when you talk about concentrated hydrochloric acid, we are talking about including the water. So if you say mass of ConHCl, it is equivalent to mass of HCl. Because you just imagine, okay, our mass of conHCl, we're talking about all the things, that will be mass of conHCl. But within it, okay, maybe only part of that is HCl. So that will be HCl. While the other one, okay, that will be conHCl. Okay, so that is the difference. So bear in mind when you write the statements, okay, to tell the others what you're calculating, so, okay, that will be the difference. Okay, so that's all for this video. Bye bye.